quite common use case for using in-memory data grids, just to scale out your persistence layer. Few words about myself. My name is Mircea Markus. I've been with Red Hat for almost 8 years now. I've been working in the clustering stack, projects such as JBoss Cache, JGroups, and in 2009 I co-founded Infinispan, which I'm currently leading. I'm also the lead for JSR 347, which is a standardization effort around in-memory data grids for Java. You can also find me on Twitter, and that's the tweet for my project. If you want to have a chat after this presentation around data grids or Infinispan in particular, or JSR 347 would be, just send me a tweet. So this is, well, it would be quite a short presentation. Two parts of it. It would be a crash course into Infinispan. So before that, how many of you have used Infinispan? Cool. How many of you have read about Infinispan, know what it is? Okay, so I'll cover that just briefly, and then jump to the use case discussion, which is putting a data grid such as Infinispan in front of a database just to scale out your persistence layer. So a few words about Infinispan. What is Infinispan? Infinispan is primarily a key value store. It is distributed. It distributes the data over multiple processes, over a network. The processes discover each other, and the data is primarily stored in memory. The total storage capacity is the sum of the node capacity or of the participants in the data grid. It has the option to overflow data on the disk, but it primarily keeps it in memory for fast access. As most of the projects in this space, it uses consistent hashing in order to achieve scalability. It is highly available, so memory is kind of volatile. In order to, so nodes crashed all the time, especially if the clusters are big. In order to avoid or to recover from failures, it keeps redundant copies of data. It is elastic in the sense that it's built in mind with the idea that nodes can be added and removed at runtime, and that shouldn't impact the users. So basically, the users that are connected to the grid should not stop the world, and the application should proceed as nothing happened, ideally. And of course, it's open source, being developed with a community, but led by Red Hat. It's ASL licensed, and we hold our source on GitHub. So this is a high-level view of the data structure or the storage engine Infinispan has. At transport layer, so this shows a cluster made out of 2 nodes, 2 JVM processes that connect over a network over either TCP or UDP. For transport, we use another JBoss project, JGroups, which is a reliable multicast library. Then on top of JGroups, Infinispan adds a storage engine, which is primarily based on memory, but allows you to overflow data to disk just to achieve more durability. We have several services on top of the storage engine, such as notifications, like when data is added, removed. Transaction. Infinispan is fully XA compliant. It implements the JTA specification. We have query. We run our indexing based on Lucene, and we provide SQL querying. SQL-like querying. Joins are not well supported. That's because of the inherent way in which we store data through a consistent hash. We also have a MapReduce API, which allows you to crunch all your data and to iterate over all your data in the grid. And we offer monitoring. I mean, it's a pretty complex system. It's a distributed system, and being able to monitor it and have alerting around it is very important for us. So we provide the management console and monitoring console. An Infinispan grid can be consumed several ways. It can either be consumed from an application which stays in the same process as it does. So that would be an embedded application. That would be this one. But it can also be consumed in a client-server mode, more like a storage engine. So you can have various applications accessing an Infinispan grid over a network remotely. That has several benefits. For one, you're not tied to Java clients. You can use C++ clients or .NET clients. We have actually several protocols which allow you to access the grid. One of them being REST. We have a memcached connector. We also have a protocol that's very much targeted for data grids, which is called Hot Rod. And that one is quite smart in the way it accesses the grid. It's binary, and it's the fastest. That one also has some pretty nice features, like it's aware of the cluster topology. So if a node crashes, that one will pick up that information and connect to it. Some key features Infinispan has: transactions, as I mentioned. It's an XA compliant data storage. So you can have a transaction like from the book example, moving money from a database into an Infinispan server, and we have full recovery support around that. So if the transaction fails, you're able to recover using the JTA recovery mechanisms. We have persistence integration. I have a slide about this shortly. MapReduce, we have our own MapReduce API, but we're currently developing an adaptation on an adapter for Hadoop MapReduce. So you'll be able to, out of the box, run Hadoop Hadoop MapReduce on top of Infinispan. That's something that we have a proof of concept for, and it's in development. We have querying. This is both in embedded mode and in client-server mode. We expose a pretty nice querying API. In embedded mode, actually, you're even allowed to run Lucene queries directly, which is quite powerful. Another feature we have, and in which we put a lot of effort in, is replicating data between data centers. So Infinispan was primarily thought of to replicate data within the same data center. But now we allow you to just have a cluster across multiple data center and have something like follow the sun, just keep your data where your customers are, or just recover from catastrophic failovers. We're also developing a continuous query feature that's to be released in Infinispan 7.0. There's a lot of demand for that, and it's quite useful for building complex event processing like applications. I'm going to talk a bit about persistence and cache stores because it's related to the use case I'm going to discuss, which is scale your database. So Infinispan allows you to overflow your data to the disk or to whatever storage you have, just to have increased durability, but also because memory is now it's cheaper, but it's still a quite expensive medium to store large amount of data. So ideally, we have several algorithms that would choose which data is hot and only store that in memory. But for overflow, a more durable persistent storage is needed. We also allow you to take data or to read data when the cluster restarts, so that it gets effective much more quicker. We have various implementations for overflowing data, like JDBC, a JPA cache store on a file, just on a single file on the file system. You can also store your data in a remote Infinispan cluster, so you can build hierarchies of clusters if you want. Cassandra Hadoop. But the important part, this is extensible, so whatever durable storage you have, it might be like a legacy system, or you can extend it and you can plug your own storage in there. Actually, the API for extending it is very much inspired from JSR 107, so it's very close to a standard. We add to that just because we're more than a local cache, so there are aspects that are not covered within JSR 107. Okay, now this is the second part. Just going to discuss about one of the most common use cases I saw Infinispan being used in. And it is a pretty common problem just to scale out a database. The problem is the problem with databases is that they are quite hard to scale out. They are not impossible to scale out, but the cost of scaling out a database is exponential with the number of users or the storage capacity you want to scale. So it's not always cost effective. So yeah, many people use grids just to put a data grid in front of a database, and grids, because of the consistent hashing, they tend to scale virtually linearly. Just to show the architecture I'm talking about. So here is a database system. It's a relational system, but it can be any storage layer really. Databases or relational databases being the most common. The architecture is just to put a grid in front of the data store and have all your clients connect to the grid, both for read and write. The grid will keep the data consistent. Because it's in memory, it's quite fast. So it's very fast for access. And the nice part is that if you need more client access or you need more data to be stored in memory, you can just easily add more nodes to your grid. And the grid will scale horizontally. The writes are also persistent to the database, of course, for more durability, and also for when you take down the grid for maintenance, you'll need to have a system of record from where to recover the data. The thing is, though, the writes to the database can happen asynchronously, so the user won't see that the grid actually communicates with the database. That won't slow down things. This is a client-server access. Normally, it's more common because databases are being accessed from more than one programming language. So you can use any of the remote protocols Infinispan exposes, such as just a Java hot rod client, C++, or a REST client. You can use all of them at the same time. I mean, you're not restricted to a single protocol for remote access. Talking about, so I described a bit the architecture for scaling out a database, but this comes with some challenges. It's not just out of the box. Normally, people using databases use a relational model, and they query the database through SQL. Infinispan and in-memory grids are inherently key value stores. So you will have to re-architect your access layer in such a way that you will use a key value store API to interrogate it. There's also a tool we develop in Red Hat, and it's an open source tool. It's Hibernate OGM, which allows you to use the Hibernate API to access a grid. So that one comes quite handy if you're already used with Hibernate, which is pretty common, and you want to access a grid. The programming model is quite different because with data grids, you don't really want to run that many joins. Joins are very expensive. If the data is not collocated, joins are super expensive because of the way they are built. So normally, you're using other ways to query your data, like serialize your query and send it to where the data is, execute it in parallel, perhaps like MapReduce, and just get the data back to your user, but don't bring all the data to your user and then just query there. So it's an aspect that's worth mentioning because the programming model is quite different. Also, there are some DB features that have a counterpart in the grid, such as DB triggers. When something is inserted, you want to take a certain action based on that. The functionality, the equivalent functionality would be the remote listeners. So you register a listener, through a client server, and you record the condition that would, so when data is being added to the grid and the condition is met, the listener will be notified. It's very much like database triggers. It's just that it's a bit nicer in a sense because it allows you to push from grid to user, which might be different processes, so on and so forth. It's also a way to build materialized views. The grid counterpart for that would be something like near caching with invalidation. So if you have, for example, a query that's being executed a million times per second, instead of doing that, you might just keep the result, and whenever something is updated, just update the result of that query. So that's another feature that Infinispan offers. Also, querying is very much like SQL querying, but joins are lacking. So joins are costly. They are not lacking. You can still execute them, but the time to execute a join is quite high. Also, security. So Infinispan has pretty solid security support. In Infinispan parlance and in JSR 107 actually parlance, you have a cache manager which aggregates a set of caches. In database, that would be a schema with a set of tables, and you are allowed to declare access control list like privileges for reading or writing to that cache, to that particular cache, like you would do for a table. Also, you can specify which users can execute what, like a user might be able to run MapReduce, another user just to read data, another user to read and write data. So that's very similar to how the database is organized, and it's normally quite important to have, especially if you're running an enterprise application, which is normally the case because if you want to scale your database to that level, it might be a pretty hardcore database. Also a slide about JBoss Data Grid. JBoss Data Grid is the commercial offering on top of Infinispan. So Infinispan is open source. It's very much, we have quite a strong community, quite a vibrant community around it. But we experiment with lots of features and cool things. Not all of these make it in the product. We only handpick the very stable one and backport them into the product. And then you get on top of the product, you'll get a fully tested stack, like on platform or on specific databases, so on and so forth. Yeah, that was my last slide. Thank you for attending. If you have any questions, I'll be glad to answer them. Also, I'll be hanging around. Just ping me on Twitter or just grab me and let's have a chat around your use cases or whatever you're interested in the data grid scope. Also, before taking questions, if any, I have a presentation around JSR 347 tomorrow evening. So if you're interested in the standard we try to build around data grids in general, it's a BoF. It's tomorrow quite late at 9:30. Just join and let's just chat. So thank you, and looking for the first question. So the question is, what if you have to do joins? Like in databases, that's quite a normal requirement. Normally, what you can do is denormalize your data. So just copy more data that would require increased storage. But another thing you can do is, so Infinispan has hinting in the sense that you can shard your data. Like, for example, if you want to have all your people that, or you're a company, I want to have all your people that are in the same office, to have them on the same node, because you normally query them like that. Infinispan allows you to collocate it. So the consistent hashing will take that into account, and it will put your data in as close as possible. And then it's much easier to run querying, to run joins. The problem with joins is that if you have a part of a join there and another part of a join there, you'll always, for every part that matches here, you'll have to do a round trip to the other node. We have some planning. I mean, we try to plan around, just to filter out more aggressively on the more aggressive condition of join, but generally you cannot expect an extremely good performance around that. So I would say denormalize your data and try to collocate it. Okay, cool. Okay, thank you. Thanks everybody for attending. I will pass the microphone for the raffle now.
We'll have you. Great job.